Okay, so there is one little last section that we are going to do called linear systems that does relate to our linear relations unit. It's actually the first thing you'll probably start off when you get into grade 10, whether academic or applied. So hopefully you remember this part. Okay, so linear systems are very straightforward. All that means to have a linear system is that you're going to have more than one line. Okay, so I have the equation of two lines. They're really nicely rearranged into the form of y equals mx plus b, both of them. So I'm going to graph one in purple, and I'm going to graph one in green, and wherever they intersect is the solution. So it's a really nice lesson based off of everything you already know. You're just going to do two lines on the same graph. So if you remember, this is your b, so this is your y-intercept. So I'm going to start at -1, and then I have a slope of 3, so that's 3 over 1, positive, so I'm going to rise 3, run 1, rise 3, run 1, and so on. We could also go down and to the left, and we're going to get a purple line that I'm going to draw in. And remember, when you draw your lines, try and make them extend through most of the quadrants, okay? So there we go. So that's our first line. Now I'm going to have this one joined by another line. So this one has a y-intercept of 7. So 1, 2, 3, 4, 5, 6, 7. And it has a slope of -1. We don't write the -1. So if we have a slope of -1, that means that we're going to have to go down 1 and to the right 1, and down and to the right, and so on. Okay? And that will be our second line. So this is a linear system. And all you have to do is be able to remember how to label a point, and you have the solution. So in this case, our points, or our lines, sorry, intersect right here at the point over 2 and up 1, 2, 3, 4, 5. So the point 2, 5 is the solution to this system. Now, if you were to verify this by algebra, what that would mean is when I put in a 2 for the x in each of these equations, I should have a 5 come out as my dependent variable, as my y. So I can check this by putting in the 2 where the x is, and yes, out pops a 5. And the same thing with this one. If you put a 2 in here, -2 plus 7, you also get a 5. That is the only point that will be able to be plotted on both lines. It will not happen. No, there are no other point that this is going to work for. Okay? So this is just basically graphing two lines and finding the point where they intersect. So I did one. The first one was a bit of a nice one. Everything's rearranged nicely. This one, it's not rearranged into y equals mx plus b form. So you're going to have to do that. And way back in the equations algebra section of the course, we talked about how important this was. So it depends on you how you want to do this. I would probably, let's see. I would probably add y to both sides. And then I would probably, well, I guess I can, let's see, let's do this. No, I guess I can stick it in green. So I would end up with 4x equals -10 plus y. And then I would probably add 10 to both sides. And I would end up with 4x plus 10 equals y. Or, I mean, you can rearrange that, y equals 4x plus 10. And here we have our slope of 4 and our y-intercept of 10. So this line here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it has a slope of 4, so up 1, 2, 3, 4, and over 1. Or you can also go negative and negative, because two negatives make a positive. So down 4 and to the left 1. Down 4 and to the left 1. And we have the first line. So something like that. Now the second one, 2x plus 3y is equal to negative 12. I'm probably going to subtract 2x from both sides. And so I'm going to end up with a 3y equals negative 2x minus 12. And then to get y by itself, I'm going to have to divide everything by 3. So this is going to result in y, because it's going to cancel out. Y is equal to negative 2 over 3x. And 12 divided by 3 is 4. So this line is going to have a y-intercept of negative 4 and a slope of negative 2 over 3. 1, 2, 3, 4. So you would go down 2 and over 3. But as you can tell, I'm running out of space here. So I could also go up 2 and over 3. Up 2 and over 3. And this is also going to give me a negative slope. Instead of going down and to the right, you can go up and to the left. And here we go. So you've done all the hard work, so do not forget now to finally state the solution, which is going to be the point negative 3, negative 2. So that's what we say is the answer. In the back of the book, you wouldn't see any of this graphing, you would just see this point to show that that's where it intersected. Okay. Now, this is difficult for some people to do, this algebra with rearranging. So there is one other way we could do it, and that's using our x and our y intercepts. So again, I haven't got these into y equals mx plus b form. What I'm going to do is, I'm going to take turns. I'm going to sub in 0 for x and figure out the y-intercept, sub in 0 for y and figure out the x-intercept, and I'm going to graph them that way. So in this case, I'm going to put in a 0 for y. So my x-intercept is 1. Okay. I'm then going to put in 0 for x. And I find out my y-intercept is positive 2. So I have, and I mean, I can see what the slope is now, and I can continue that on with some more points, just so that I can make my line a little bit more accurate. Because if you end up going off, even by a little bit, it can really distort your line, and it may not intersect where it's supposed to. Okay, and I'm going to do the same thing for this one. I'm going to put in a 0 for the y and solve for the x. So negative 2. And then I'm going to put in 0 for the x, and it's going to be negative 4. So here's my second line. Now you're probably seeing that there is a dilemma here. Is my graph not big enough? Where do they intersect? Well, they could intersect way down here or way up here, and we just can't see it. But as a heads up, this is the trick to this one. If you were to rearrange these, okay? So if instead of doing it using the intercepts, you actually rearranged it like we did in the last one, you would get y equals negative 2x plus 2. And this one, 3y equals negative 6x minus 12, y equals negative 2x minus 4. So here we have a line, y equals negative 2x minus 4. And here we have the line y equals negative 2x plus 2. What do you notice about the slopes of the lines? That is right. They are the same. And if two lines have the same slope, that means they are parallel. And the answer that you would write for this one is that there is no solution. These lines will never meet. They will never intersect. And as a result, there will never be a solution. Okay? The only other tricky thing they can do is sometimes they can try and make the lines look different, and it's exactly the same line, one right on top of the other. And in that case, fancy schmancy, you have an infinite number of solutions. Okay? All right. That's it for today.